Okay, you guys, so this is 2.6, and 2.6 is historically the hardest unit in Chapter 2. And so I'm going to do this video lesson, and I'm sorry that I'm not there right now, but I promise we'll spend a lot of time on this. In fact, we'll do some problems every day with this lesson. So what is a literal equation? A literal equation is an equation with multiple variables. And I think the important thing is this is huge in science. So in science, you're going to have so many different formulas that you're going to use, and they're all going to be literal equations. So for example, you know some of them right now. So area equals length times width, or area of a triangle is 1/2 base times height, or volume is length times width times height. So these are literal equations, a whole bunch of variables, and sometimes we know what they are and sometimes we don't. And especially as you get into physics, these get even bigger, okay? So this seems very simple, but I want to talk through the steps of this. So if we were going to solve this for just x, we want to get x by itself. We're going to isolate x. So we do reverse order of operations. So the first thing I do is add 5 to both sides, and I have 2x equals 18. And then I'm going to divide both sides by 2, and this gives me x equals 9. Now, the step in a literal equation is exactly the same. So you have to find your x value. You have to use the reverse operation to get x by itself. So right now, the negative b is not connected, right? A is attached to x, so we're not going to touch the a. We have to move the b first. So I'm going to add b to both sides. So my left side just stays ax. Over here, c and b are not like terms. If they're not like terms, I can't combine them. So what I have is just c plus b. Or you can say b plus c. Either case, right? So we know from commutative property we can switch these back and forth. All right, next step is to get x isolated, so I divide by a. Now, when I divide by a, I'm dividing the entire thing by a. I don't just divide one variable, I'm dividing the whole thing. And normally when we do this, we've already combined over here, right? So over here we combined, we ended up with just 18, but since I can't combine, I have to divide the whole thing. So this cancels out, and I get x equals c plus b over a. And that's my answer. So if I'm solving for x, this is what it would look like. Now what's going to happen is you're going to be told what variable to solve for. So you have to make sure that when you're isolating whatever variable you're solving for. Okay? So what I want you to do is I want you to pause this and I want you to do a little quick write on this. So identify what was the same between these two and what was different between these two. All right? So go ahead and pause this, write those down, and then I'm going to pop back on. Okay, if I had to come up with a similarity and a difference, I would say that my similarity is that both use opposite operations to isolate the variable. So isolate the variable. All right, my difference is that the literal equation doesn't simplify before dividing. So I end up with all of my variables, which you should. You should end up with all of your variables. Okay, all right, so let's look at some of these. And I'm going to solve the odd ones for you. Okay, so here it says we're solving for w. So w is the variable that we want to isolate. So I have to move everything that's attached to the w. So the only thing I have here is L. So this is an area formula, length times width. So I'm going to divide by L and divide by L. So my L's go away on this side. And I have A over L equals W. And then I can use my symmetric property and I can rewrite this, W equals A over L. Okay, so for this next one, it says solve for t. So if I solve for t, I see that I'm multiplying r times t. So if I'm multiplying r times t, and this is distance equals rate times time. So you'll use this year with Mrs. Guthman. So distance equals rate times time. So I want to isolate the t. I multiply right here, so I have to divide by r and divide by r. My r's cancel out on this side, and I have t equals d over r. Okay? Now, if I look at number 5, I've got 3 variables. I have a volume equation, length times width times height. So I'm solving for h, so h is what I want. Now, what I have here is length times width times height. Okay? So I'm multiplying all of this together. So if you think about this, if these were numbers, they would be multiplied together. So what I'm going to do is I'm going to divide by length times width. I'm multiplying these two things together. So length and width goes away over here. I multiply by length and width over here. So I have h is volume over length times width. Now, you'll notice I have my multiplication dot, and over here I got rid of it. And you could keep it in there. It's not wrong if you do. So I'm going to show you something different on number 5. So volume equals length times width times height. And we're solving for h, right? So I can divide this by w. So I'm going to divide by just one variable. So my w's will cancel out. So I have v over w equals LH, right? Because when I divide by w, my w's go away. So now I'm going to divide this side by L, and this side I have to divide by L. So if I'm dividing, it's going to go in the denominator. So now my lengths cancel, and I have v over WL equals height. So I end up with the same answer. So you can do this in multiple steps if you want to, or if you see, hey, these are multiplied together, I'm just going to divide by that. Okay? All right, I'm going to go over here and do number 6 because number 6 is tricky. So on number 6, we're solving for r. Now, we have pi. Pi is just a number, so we could use the value of 3 for this. It doesn't really matter. So what I'm going to do is I'm going to divide this side by pi, and I'm going to divide this side by pi. So what I have is a over pi equals r squared. Now, I'm going to flip this around. I'm going to use symmetric property right now and get the r on the other side, just because this hurts my brain. So a over pi. Okay, I have not solved for r. I solved for r squared here. So here's the tricky part. How do we get r by itself? So to get r by itself, if r is squared, to get rid of a square, we have to take the square root. So if I take the square root of this side, I have to take the square root of this entire side. Now we've done this so far this year. Remember, we had problems that looked like this, right? We take the square root of the top, the square root of the bottom. And so that's what this is. Now, here's the key. When I take this value, and now on the left-hand side I have r, I don't know if this r value was positive or if this r value is negative. I could have negative 2 squared, which would give me a positive number. I could just have 2 squared, which would give me a positive number. So because of this, on my square root over here, I have to have positive and a negative value of a over pi. So here's the takeaway on this. With a squared value, so if I have something like x squared equals 4, if I want to solve this, I take the square root of this side, the square root of this side. This gives me just x. And then on this side, I have to have a positive and a negative value of 2. And here's why. Remember, if I plug it back in over here, I would have negative 2 squared. If I plug in just the positive 2. So either case, this gives me a positive 4 value. So when I solve a square root, when I get the squared variable isolated, I have to have both a positive and a negative value there. Okay, I'm going to do one more. I'm going to do number 7. So number 7, I have c minus s, so I'm solving for c. So if I'm solving for c, then the s term is what has to move, right? So if I'm subtracting, I have to add s. So I add s over here. So m and s are not like variables. So I have m plus s equals c. Okay, I'm going to pause this, and I want you to go ahead and work 2, 4, and 8, and then I'll pop back on, okay? Okay, y'all, so what you see here is that I isolated the variables, and this is what your solutions should look like. Okay? All right, so let's flip it over, and we're going to look at some harder problems now. So now we have some multi-step problems. All right, so this is not any different than the way we solve anything else, but for whatever reason, variables get people jammed up. So we're going to do reverse PEMDAS, so reverse order of operations. We're going to remove the fractions by multiplying by the reciprocal. And then last is we divide by whatever the variable is. Okay? So let's look at this first one. I have this variable h. So if I'm solving for h, the first thing that I want to do is get rid of this 1/2. So it's a fraction. So to get rid of the fraction, I'm going to multiply by the reciprocal. So the reciprocal is 2 over 1, which is just 2. So if I multiply this side by 2, I multiply this side by 2. And if you still need to do this 2 over 1, that's okay. So what I end up with is 2a equals bh. And now, since I'm solving for h, I have to get rid of the b. I'm multiplying. So I'm going to do the opposite. Opposite is divide. My b's cancel, and I have h equals 2a divided by b. Okay, so for this next one, I'm solving for m. So if I'm solving for m, I have to get m by itself. So first thing I'm going to do is clear the denominator. Remember, the whole thing here is a fraction. So if the whole thing is a fraction, I have to clear the denominator. So if I'm dividing, I want to multiply by 2. Over here, I multiply by 2. And then my 2's are going to cancel out. So what this gives me is 2k equals mv squared. Now, this problem is not like the area problem that we had over here. So area equals pi r squared. So area of a circle, this is what I have. Now, I was isolating r, and r was my squared variable, so I had to take the square root. Here, I'm isolating m. m is not my squared variable. So what I'm going to do is I'm going to divide by v squared, because v squared is what I need to move. So on this side, I divide by v squared. So my v squared terms are going to cancel out. And I get m equals 2k over v squared. Now, I'm going to go over here and I'm going to do this. So let's just say, let's go back to the step where I have 2k equals mv squared. And let's say that I'm trying to isolate v instead. Okay, so I'm going to divide this side by m and divide this side by m, and this gives me 2k over m equals v squared. Well, if I'm isolating v, right, now I have a squared term. So now I have to take the square root of both sides. So if I take the square root of both sides, I'm going to use symmetric property here, get this on the other side for me, is I have v equals, remember when I take the square root, I have to have a positive and a negative value for v, 2k over m, and you'll see the entire thing is under the radical. All right, so it's very different. Here, if I'm solving for v, I end up with the square root, but here I'm solving for m, so v squared is going to stay. All right, I'm going to do one more problem, and then I'm going to let you practice this with your table. And so I'm going to do number 13. So number 13 is perimeter, 2 length plus 2 width. And if I'm solving for w, I'm going to do reverse operations. So let's just say this is a number. I know there's a variable in there, but let's just say this is a number. So I need to get rid of that one first. So I'm going to subtract 2l from both sides. So this side goes away, and I end up with p minus 2l equals 2w. Now, when I do this, these are not like terms, so I have to keep them separated. And now I divide both sides by 2. So I get w equals p minus 2l over 2. And this is my answer. Now, very common mistake and something that can't happen is I can't cancel these 2's. I can't reduce this. And I can't reduce it because the 2 also goes to the p. So this is the same, leave it in this form, leave it in this blue form, but I want to show you what this is the same as. This is the same as 2 terms with a common denominator. I have p over 2 minus 2l over 2. So if I broke this out, I would have a common denominator, right? And so what we do is we smoosh it all together and we have one denominator, and this is the correct answer. If you have this, technically, I'm going to go up here, I have p over 2 minus l. Because here I can cancel my 2's because it's not connected to anything else. I cannot do it on the blue. I can't do it here because the p still has this denominator of 2. So this, simplified, would be the same as this. So these are equivalent. They're the same. Okay? All right. We're going to pause the video now, and I want you to work through the rest of these. I'm going to go ahead and put the answers up so that you can look through this. Actually, let me just do this now. I don't want you to be tempted, so pause the video, and then this is what the final solutions are going to look like, okay? And so you can look at these as you go through this, okay? So let me move this back up so you can see the bottom two right here. All right, we will practice this in class, so your homework will be over absolute values because these are a little tricky. So make sure you come and see me if you're lost on this, okay? Thanks.